Ever wondered why Mercury, the closest planet to the Sun, is so small? It's a question that has puzzled astronomers and space enthusiasts for ages. Nestled in the Sun's fiery embrace, Mercury, the tiny sun-kissed planet, is a fraction of the size of its planetary siblings. But why is that? Is it due to its proximity to the Sun, or is there another mysterious factor at play here? Well, today we're going to unravel the mystery behind Mercury's surprisingly small size. To understand Mercury, we need to look at the data from NASA's MESSENGER spacecraft. This intrepid explorer was launched into the cosmos with a sole purpose: to study Mercury, the smallest planet in our solar system. MESSENGER, an acronym for Mercury Surface, Space Environment, Geochemistry, and Ranging, was a mission of discovery, aiming to fill in the gaps in our understanding of this tiny, sun-kissed planet. The spacecraft's journey was not an easy one. It took over 6.5 years to reach Mercury, but the data it collected was worth the long wait. Using advanced imaging systems, MESSENGER captured comprehensive images of Mercury's surface, revealing features that had been hidden from our view. One of the most striking discoveries was a complex system of ridges and cliffs known as lobate scarps. These formations indicated that Mercury has shrunk by almost 9 miles in diameter over 4 billion years due to cooling. This contraction is ongoing and could even be causing Mercury quakes. The MESSENGER spacecraft has given us invaluable insights about Mercury, especially about its size. It's not just that Mercury is small, it's that it's shrinking, a fact that raises fascinating questions about the planet's past and future. Now let's delve into the fascinating discovery made by MESSENGER. Imagine a planet, all alone in the vast expanse of space, quietly shrinking. It's not a rapid process, but a slow, gradual contraction over billions of years. This is the reality for Mercury, the tiny, sun-kissed planet closest to our own sun. MESSENGER, NASA's intrepid little spacecraft, made a startling discovery during its mission. As it journeyed across the surface of Mercury, it captured images of a fold and thrust belt, a clear sign of geological change. This data indicated that Mercury has actually shrunk by almost 9 miles in diameter over the course of 4 billion years. Now, that may not sound like much, but for a planet that's about 3,000 miles in diameter, it's a significant change. So what's causing this celestial shrinkage? Well, it's all down to cooling. As Mercury cools, its interior contracts, and this contraction causes the surface to crumple and form ridges and cliffs known as lobate scarps. It's a bit like how the skin of a fruit wrinkles as it dries out. The fascinating thing is, this contraction is believed to be ongoing. That's right, Mercury could still be shrinking even as we speak, possibly causing Mercury quakes, similar to our earthquakes, but on a much smaller yet equally intriguing scale. This revelation has not only expanded our understanding of Mercury, but also raised some intriguing questions about the planet's history and geological processes. It's a reminder that the universe is constantly changing, evolving, and full of surprises. Mercury, it seems, is not just the smallest planet in our solar system, but it's also getting smaller. This discovery underscores the importance of space exploration and the role it plays in shedding light on the mysteries of our universe. So it turns out, Mercury is not just small, it's also getting smaller. The shrinking of Mercury has had some very interesting consequences. The planet's contraction has triggered the formation of unique surface features, most notably, the lobate scarps. These are essentially ridges and cliffs that have formed as the planet's crust crumples in response to its shrinking interior. Picture a raisin drying out, its skin wrinkling as the inside contracts. That's a somewhat simplified version of what's happening to Mercury. But the story doesn't end with these fascinating features. Mercury's ongoing contraction may also be responsible for something quite unexpected: Mercury quakes. Yes, you heard that right. Much like earthquakes here on Earth, Mercury quakes are seismic activities, but they occur on the surface of Mercury. These quakes are believed to be a result of the planet's continuous contraction. As Mercury's interior cools and shrinks, the surface is put under stress, causing it to crack and trigger these quakes. Now, these Mercury quakes aren't exactly like our familiar earthquakes. They're not caused by tectonic plates shifting, as there are no tectonic plates on Mercury. Instead, these quakes are a direct result of the planet's contraction, making them a unique phenomenon in our solar system. Mercury's contraction and its resulting effects provide us with a captivating look into the planet's history and geological processes. It's a prime example of how dynamic and ever-changing the universe is. Even the smallest planet in our solar system is packed with geological activity and continues to evolve over billions of years. Mercury, it appears, is a planet full of surprises. But what does all this information about Mercury's shrinking size really mean, you may ask? Well, it's not just about the size of the planet. MESSENGER's findings have far-reaching implications that go beyond the confines of this tiny, sun-kissed planet. The revelations about Mercury's contraction have raised intriguing questions about the planet's history and geological processes. It's like trying to solve a 4-billion-year-old mystery. The question of why Mercury is shrinking is also a question of how this planet has evolved and transformed over the eons, and what forces have been at play. But the implications of MESSENGER's findings don't stop there. They also shine a new light on a theory from the 19th century about Earth's mountains. This theory proposed that the formation of our planet's mountains resulted from the Earth's contraction, similar to what we're seeing with Mercury. For years, this theory was sidelined as plate tectonics became the accepted explanation for the formation of Earth's mountains. But MESSENGER's findings have brought it back into the spotlight. Now, scientists are looking at this old theory with a fresh perspective. This doesn't mean that plate tectonics is being dismissed. Instead, it opens up a possibility that our understanding of geological processes is not one-size-fits-all. Different planets may have different geological stories to tell, and Mercury's story is one of contraction and shrinkage. This underscores the importance of revisiting past scientific ideas. Science is not static. It's an ever-evolving field where old theories can gain new relevance in light of fresh discoveries. And MESSENGER's findings are a perfect example of this. So the next time you look up at the sky and spot that tiny dot near the sun, remember that it holds a story of a planet that has been shrinking for billions of years. A story that has made us rethink our understanding of planetary processes and revisit century-old theories. These findings remind us of the importance of revisiting past scientific ideas and of keeping an open mind. After all, the universe is full of surprises and we're just beginning to uncover them. So there we have it. The mystery of Mercury's small size, solved. We've journeyed through space, hitching a ride with NASA's MESSENGER spacecraft, and delved into the secrets hidden on Mercury's craggy surface. From the revelation of its fold and thrust belt to the ongoing contraction that's causing the formation of those intriguing lobate scarps. The planet's shrinkage over 4 billion years, around 9 miles in diameter, is due to cooling, possibly even causing Mercury quakes. The data from MESSENGER has not only given us a more complete understanding of Mercury, but also highlighted the importance of revisiting past scientific ideas. It has thrown light on the 19th century theory about Earth's mountains forming due to contraction, proving that old ideas can still hold weight in modern science. This journey into the cosmos underscores the importance of scientific exploration and the pursuit of knowledge. The more we explore, the more we understand, not just about far-off celestial bodies, but also about our own planet. So as we continue to probe the mysteries of the universe, let's remember that each discovery, each piece of data, each image from a spacecraft like MESSENGER plays a vital role in our collective human understanding of space. Remember to like and subscribe, and let us know what you think of all this in the comments below.